Hello and welcome to Alibaba Cloud. My name is Ankit Kapoor and I am a database solution architect in Alibaba Cloud. In today's chapter, we are going to discuss MySQL transaction flow for InnoDB engine. So, MySQL is one of the most popular database these days and it has been widely used by Alibaba customers to achieve good performance or to achieve high data security for their OLTP applications. In this chapter, we are going to discuss how any queries like DDL, DML goes through various components and how it can help you to achieve good performance or the data securities. So yeah, let's go and let's deep dive. So in this chapter, we will be discussing the cloud native databases. Then we will be switching on to the why this session is required, because we are here, we need to know why we are here and what is the outcome. And then we will be discussing the glossaries, that is the terminologies, and how these terminologies will help you to understand the architecture. So it is very important for you to know the meaning of those glossaries. So I will not go in the details of all those glossaries. I will explain you as and when it comes in the architecture. So this is our cloud native engines. Then we have open source engines, we have commercial and NoSQL engines. So when I say cloud native engines, I mean that these are the databases which has been developed by the Alibaba and which follows the architecture of storage, compute, decoupled. So we have three flavors. We have Oracle, we have MySQL, and one is PG, that is Postgres. So this kind of databases can be used for those businesses where they expect some kind of high traffic. So let's say you have a business where you want to go for some shopping festival and you are expecting some high traffic during those period of time. So you can scale your storage as well as the compute layer, and then once business is done, you can reduce your configuration. So it will help you to reduce your cost and achieving your business requirements. Then we have open source engines. We have MySQL, MariaDB, and Postgres. So MariaDB is a fork replacement of MySQL, and the developers of both are same. But now MySQL has been carried by Oracle itself, so they are maintaining the source codes. Then we have commercial and NoSQL. We have MongoDB, we have SQL Server, we have Cassandra. Now let's talk about the features we have and how it can help you to achieve your requirements. In RDS feature, when you launch any MySQL instance, you have an option for deciding what storage type you want. So we have SSD, we have eSSDs. So under SSD, we have two options. One is local SSDs and one is cloud SSDs. So local SSDs are ones which are closer to data to reduce IO latency. So I can say local SSD is housed on the same server as the database engine. So if you use local SSD, you can achieve low latency. And then we have cloud SSDs. Cloud SSDs is an elastic block storage device designed based on the distributed storage architecture. And then we have eSSD, that is E for enhanced SSDs. So enhanced SSD is an ultra high performance disk provided by Alibaba Cloud based on the new generation of distributed block storage architecture. It integrates 25 gigabit Ethernet and it uses RDMA technologies. So RDMA is remote direct memory access technology, and why it has been used to reduce latency and to deliver 1 million IOPS. So let's say you have a requirement where you're gonna go for the scalability. You can choose eSSD or cloud SSDs. Or let's say you have a requirement where you want good IO performance. You can go for the local SSDs because it is much closer to your compute part. Then we have single AZ and multi-AZ. So in Alibaba RDS MySQL, whenever you launch an instance with a high availability, you have two options. One is single AZ and multi-AZ. What I mean by that is, so whenever you launch high availability instance, one, your primary node will reside in the same zone where your standby node, or you think from this point of view that your primary node and standby node or your hidden node will reside in the single availability zone. And this can be useful for the cases where you achieve or where you want a low latency. And in those cases where you want to go for the multi-AZ, or you want to place both of your instances, that is primary and the standby, in different availability zones, you can place or you can use multi-AZ. Then we have enterprise editions. Apart from basic, which is being used for the development purpose, and then HA, we have enterprise editions. So enterprise edition generally use three different database nodes and in 3 different AZs. So this has been useful much for the fintech business. So I will not go into detail. We will focus on enterprise edition in our next chapters. And this is more exciting to know. Then we have multiple instance types. So what I mean by multiple instance type is that whenever you are launching the instance, you have an option to decide whether you're going to go for general purpose or you're going to go for the dedicated instances. Then we have an option of multi-zone migrations. Multi-zone migrations are those, let's say your MySQL or your data is in one zone, in zone A in Mumbai region, or you want to go and you want to migrate to zone B. You can just do it by clicking. So that is also possible, but just to note you that this option is available only in the MySQL 8. Then we have automatic and manual upgrades. So let's say you want to go for the upgradation of your MySQL. You can just decide the time, or immediately you can do that. Then we have backup and recovery. So we have different backup policies here. So we have logical backup, we have physical backup, and we have snapshot backups. So for local SSDs, the only option you have is for the logical as well as physical. But if you want to go for snapshot backups, you have to use either eSSDs or either cloud SSDs. Depending on your needs, you can go for any of these backups, but that does not limit you. You can go for physical or logical backup, even in the case of eSSD, but SSDs also. So that depends on your needs. Then we have monitoring and alerts. So like if you want to go for more enhanced monitoring, you want to see what happened during a instance or during some point of time, you can go for the monitoring and alerts. And also, apart from this, third-party alerts like Datadogs are also there, but you can here opt and create your own alerts. Then we have read-write split. What do I mean by read-write split? So let's say you want to divert your all read traffic to all your read nodes, not to your write nodes. So you can just split your traffic. Then we have automatic failover. So in this case, if your master goes down, automatically your HA node will come up, or I say standby node will come up. So your application does not need to worry about, so it will remain same. As I have mentioned before, yes, it follows ACID compliance. Then we have routine maintenance. So what I mean by here is that, let's say you are using MySQL. So in early RDS MySQL, we generally use the latest mini version, that is latest some minor versions. So let's say you are using 8.0.5 and you want to upgrade to 8.0.20. You can set your routine and it will do that upgradation part. And it will also do your regular maintenance things. Push button scaling. So what I say is that it's kind of elastic scalings. So if you want to upgrade your storage or compute, you can do it just by following on the RDS console. So these are the RDS features which we have in MySQL. Now let's know why this session is required. So first of all, there are various requirements where we want to decide whether we want to go for performance as well as security. So this architecture will help you that this kind of settings will give me good performance, and This kind of setting will give me good data securities. And then we have option of how to increase the database performance, and then how we can ensure that that our application is fully ACID compliant. Then we learn different components involved in transaction flows. Yeah, so these is the reason that why we are here and how Alibaba helps their customer to achieve either of these securities. Let's move. So this is the glossaries. I am expecting these glossaries or these terminologies to be aware of, because these terminologies will help you in understanding the architecture. So I will not go into all of these details. So what I will try to do is that I will cover all these glossaries as and whenever it comes in the architecture part. So let's start the architecture. So this is the rough architecture I can see here. So what I mean by rough architecture is because I haven't designed in the more presentable format, because I'm a technical guy. So I focused mostly on the important things that we have and how it can help reader or the viewer to understand it. So we have different components involved. We have redo log buffer. It's a kind of buffer area or kind of memory area which resides to hold the transactions. Then we have IB log files, that is your redo log files. Then we have binary logs. Binary logs are files of MySQL which holds the changes which has been happening into your databases. Then we have InnoDB buffer pool. We have buffer pool is a kind of complete area which has been devoted to the MySQL. And we have buffer pool size. So buffer pool size means how much memory you want to give to your MySQL to do its operations. Then we have change buffers. Change buffers hold the changes which is happening into your secondary indexes. Then we have undo logs. Undo logs and how it helps in achieving isolation, which is I in the ACID properties. Double write buffers. And then we will discuss the fuzzy checkpointing mechanism and the other checkpoint mechanism. We will discuss what is flush and what is the different flushing methods which MySQL use for the different operating systems. So if you see here in this architecture, so whenever you execute any query, it will firstly go into the redo log buffer. From here, it goes to your InnoDB log file size, or I can say your IB log file, that is your redo log files. And then from here, it flush to your disk, that is your physical file. So that's why I have mentioned these components, these variables here, and how it helps you to achieve performance over security or security over performance. So also, if you have enabled your binary logs, then also your query will go apart from the redo log buffer to the bin log cache, and then also to the InnoDB buffer pool. So first point is redo log buffer, and if binary logs are enabled, then also bin log caches. Now let's segregate these things into different parts. But before that, I wanna explain some basic features or some basic variables. So InnoDB flush log at TRX commit is a variable which focuses on how the data will be flushed from your log buffer to your log file. So there are three values. One is 0, 1, 2. So I have mentioned one here is that whenever there's any commit, your transaction will flush from buffer to your redo log file size. So yes, but this is increasing your IOPS. I can say for every commit there is IOPS. Now let's segregate this complete architecture. So step 1. So redo log buffer is the first place where transaction leaves its impression and remains there until it commits. So as I mentioned that redo log buffer are the first entry points of your transactions, and it remains until unless there is no commit which is happening to your transactions. But let's think from this point of view. If in case your redo log buffer gets full, then what should it do? It will go to your redo log files, which is, I can go back again, which is in the IB log file size. So I can say that your redo log files also contains uncommitted transactions because your redo log buffer is full. So now if you have good size of redo log buffer, your flushing will be less. So your less data will go into the redo log files. So in this way you have achieved less IO. But if you want to go for one, you can achieve high data security. So even in case of any kind of crash, you will achieve the data securities. So it's up to you if you want to go for performance or you're going to go for security. But the ideal setting is one, because it saves your data from getting lost. So as I mentioned here, if redo log buffer is small and transaction needs to go in IB log file, it resides there. So if InnoDB log buffer size is less, it will go to redo log files, and thus amount of flushing will be higher. Having required amount of this buffer will reduce flushing and help in reducing IO. And then also your query goes in the undo logs. Undo logs can reside in the IB data one or in the InnoDB buffer pool. It depends on your configuration. So the role of undo log is to show history of your old data or to roll back the transactions. So undo logs are also involved in the execution of a transaction as it is started. So now there are two purposes of undo logs, as I have mentioned: make record changes, history available to other transaction as records are changed. So this is a part of the isolation. So as you know, we have different isolation levels. We have repeatable read, we have read committed. So how you want to achieve the isolation, you can decide from the undo logs, or undo logs will help you out. Then also undo log will help you to going back to records original state in a rollback operation. So let's say if you have updated some wrong column or some wrong data, undo logs will help you to recover those part. And then transaction also goes to the bin log cache if bin logs are enabled. So these are the 3 points where your transaction first comes, but it depends if your binary logs are enabled or not. So if you want to see what is the transactions, how it is going now. So undo log records used to store modifications to table records to comply with different isolation levels. And they are also known as history list. So we have an option in the MySQL where we can check all the transactions, and that is known as show engine InnoDB status. So under the transaction list, you can see that we have a history list, which says the list of transaction with deleted marked records, and they are scheduled to be processed by the InnoDB purge. So purge is an option which deletes the old data. So as per this photo which I have taken from my system, it says the history list length is 10. So the number of records are 10, which needs to be purged from the undo logs. So if the length of the history list is reported by the command is quite large, then we need to go for the further operations. We need to decide the values and how it can be reduced. And having this value quite less will help you achieving good performance. But if it is quite high, then yes, it can affect your database performance. So this is the work of undo logs. And now coming to the bin log caches. So bin log cache, as I have mentioned, they are involved when any transaction comes. So at that same time, the open transaction is buffered into the redo log. It comes here and it goes directly to the binary log files before receiving the, or I can say before executing the commit. So here you can see that once transaction comes from client to the bin log cache, and if bin log cache receive the commit, bin log, that is the MySQL.bin log file, will commit that particular transaction first before getting executed. So in this way, it is help you in achieving the consistency that okay, your data will not be lost even if in case of crash. Now there is one more point which needs to be discussed. There is sync bin log parameter. Sync bin log parameter tells you that whether you wanna sync your bin log files or not. So let's say the number of sync bin log group. So if it is 0, then it is disabled. So but if you wanna enable it, you wanna decide how much in a group you wanna I can say you wanna commit those transactions. So I can say default behavior is that one commit group is written and flush to bin log file. So by every commit, it will flush to the bin log file. But yes, it is safe, but again, it is increasing your flushing, that is your IOPS. So now here again, you need to decide if you want to go for performance or your securities. So this is the first level entry of redo log buffers, undo logs, and the bin log cache. The next step, that is the redo log file. We will learn how redo log file is helping you in achieving the durabilities, that is the D in asset, and how it is flushing the data to that physical file. So from redo log buffer, the redo log file is a permanent place where a transaction is stored. That is to ensure the durability. Even before InnoDB data files are finally updated to reflect changes brought by the transactions. Different information can be flushed from the redo log buffer to the redo log file and at different times. So as I've mentioned, if this is full, your transaction, your even uncommitted transaction will go here. So we can say it's a kind of write ahead logging. So that's what I have mentioned here, that write occurs before getting reflecting to IBD or InnoDB file. So even if in case your data is missing, it can be recovered from your redo log files. Now let's talk about the flushing mechanism. Now once the data has been logged into the redo log buffer, now it needs to be on your physical disk. Now redo log buffer is not big enough. If it is not sufficient to contain the whole transaction, the uncommitted transaction can be flushed to disk, as in the case of lots of records or huge blobs are written. So now the configuration of InnoDB log flush at TRX commit plays role here. To increase performance, flushing from redo log buffer to redo log file can happen at each transaction commit or every 1 second. So again, you can decide whether you want to go for 0, 1 or 2. And then you can decide in what kind of amount of transaction, that is the group, you want to flush onto your physical files. So again, these kind of things can be taken from the show engine InnoDB status. So you can see from this photo, it says log sequence number. Log sequence number, it's a kind of for every transaction there's a LSN. Then we have log buffer assigned up to this we have this assigned this number. Log buffer completed up to, okay, we have completed, the buffer has completed all those flushing up to this point. Log written on the physical file up to this point, flushed up to this point. So you can see all the logs has been successfully flushed to our physical file. And this is the ideal condition. But if in case it is quite less or quite lagging, then yes, we need to optimize our flushing mechanism. We need to change the values of InnoDB log flush at TRX commit. So here redo log file usage, progress of checkpoint, and redo log buffer usage can be monitored. So as I have mentioned, it can be monitored through the show engine InnoDB status like this, or you can use other tools like InnoDB OS log written. InnoDB OS log written is a kind of variable which tells you how much log has been written to your redo log files. So this is how when your data finally written to the log files. Now let's go to the step 3. So now when the commit is received, so this is basically for the commit part. Now when the commit is received and bin log enabled, then data from cache to physical bin log file will be flushed before commit executed. I think you can ignore this point. This has been made by mistake. So once we receive the commit, the changes will be logged into the MySQL bin log file. And same is for the redo log buffer and has been reached to the physical files. So data will be flushed to disk for redo log file, that is IB log file 0 or 1. This is a physical file. Modified pages or dirty pages will be flushed. So dirty pages are ones which has been changed. Will be flushed to table space as per the flushing methods like fsync. Fsync is a flushing methods of Linux, and odirect, it is also the flushing method for your OS. So just to conclude this, when a transaction is committed, the following actions are performed. I can say these are the actions which I have mentioned here. So transactions are written from binary log cache to the your MySQL bin log file and has been flushed when commit is received. But the point to be noted here is that it should be right before the transaction is committed. Redo log buffer is written to the redo log file and flushed. And then in the last, as I have mentioned, modified pages or dirty pages will be flushed. One more point which needs to be taken care of about the dual transaction, that is the XA transactions. So as I have mentioned that XA transactions are involved to ensure consistency with the help of bin logs and InnoDB engines. Let's say at the time of auto recovery, you might notice that bin log tries to ensure consistency between data in it and in the data files. So just try to crash any of your test database and see the recovery part, that is the manual recovery. So MySQL do the manual recovery, or I can say the auto recovery, sorry for that, but it do the auto recovery part. So XA transaction is completely different and it can be useful for a different topic which we can discuss. So this is the commit step. Now let's go for the last step, which is post commit and how it performs. So once a transaction is committed, different actions are still pending to be executed. So as I have mentioned, we have dirty pages, we have change buffers, we have undo logs also. So let's talk about one by one for the change buffers index first. That is, so as I mentioned before, the change buffers contains the changes which happen to your secondary indexes. So once commit has been done, after post commit, it get merged to your dirty pages or to the changes which has happened. So I can say periodically the purge operation that runs when the system is mostly idle or during a slow shutdown. That depends on the OS. It's completely OS process. Then about the buffer pool dirty pages, which is mentioned here, is that so InnoDB implements a checkpoint mechanism known as fuzzy checkpointing. So in fuzzy checkpoint, it says, okay, that up till this point I have flushed your data. So InnoDB flushes modified data pages, the pages which has been modified from the buffer pool in small batches. So it does not flush your all data at once, but it do in the various chunks. So there is no need to flush, as I mentioned, there is no need to flush the buffer pool in a single batch. It will impact your performance. And now that's why it do it in a various chunks process. Now the last is the undo logs, that is your history list. So a history list or undo logs will purge when transaction finished. So let's say when rows are modified or deleted, the rows, or I can say the corresponding undo logs are not physically removed immediately. So let's say you have made the changes, the undo logs will not get deleted or the purge as soon as the transaction finished, but it will take time. So the old data is preserved until transactions that started earlier or concurrently are finished, so that those transactions can access the previous state of modified or deleted rows. Thus, I can say the long running transaction can prevent InnoDB from purging data that was changed by a different transaction. So this is how the post commit operation is done. As I mentioned, undo logs, dirty pages, and the change buffers. So this is the step after post commit. So just to summarize this thing, we can go back into our architecture and see how we can achieve the performance. So if you want to go, if you want to go for the data security, you can achieve, or you can change the InnoDB flush log at TRX commit to 1. In every commit, the data will get flush. And then also with different values like 0 or 2, it will be flushing in every seconds. Then we have IB log file 01. We can also decide the time at what time we wanna flush those files. We can start from 0, 1, 2, 3, and then up to our requirement as per the group commits. Then we have an option to decide what is the memory we wanna give to the MySQL. If it is more, it will helpful for your database performance. But again, you need to analyze as per your needs or as per your database architecture. Then we have sync bin log. Again, it will be helpful for achieving syncing between your bandy logs and your bin log caches. So I can say redo log helps in the durability part because it is logging the data before write ahead. Then we have MySQL bin logs, which helps in achieving consistencies. Then we have undo logs, which helps in achieving isolation, and then at least we have atomicities, which we can achieve by following this architecture. So I have covered all those segregation steps 1, 2, 3, and 4. So I think this will be quite helpful for you. And if you have any questions, please feel free to contact me or drop your queries, and I will be more than happy to help you. Thank you guys. Thanks for joining this session. I hope you enjoyed. I hope it is kind of more technical, but I hope it will be useful for you. So please follow this architecture for achieving good performance. Thanks for joining. Thank you.